myself Archana Sharma, and from Noida Institute of Engineering and Technology, Pharmacy Institute, and I am here to represent my lecture on the topic rheologic properties of emulsion. Okay. So, phase inversion. What is phase inversion? Whenever there is a change in a emulsion type, that is from water in oil to oil in water type or vice versa. This problem or this change is called the phase inversion. So, phase inversion means a change of emulsion type from oil in water to water in oil or vice versa. This technique is used to prepare stable and fine emulsion. Phase inversion can be obtained by two ways: changing the chemical nature of the emulsifier. For instance, an oil in water emulsion is prepared using sodium stearate, then calcium chloride is added to form calcium stearate, which is oil soluble. Therefore, oil phase becomes the continuous phase and water in oil emulsion is produced. Okay. So, we prepare the emulsion by by changing the chemical nature of the emulsifier. For example, and if we choose to prepare an oil in water emulsion of sodium stearate, and then we added a calcium stearate, okay, which is more oil soluble, there is a phase change, and instead of oil in water, then water in oil emulsion is produced. Then altering the phase volume ratio, that is the ratio between the water to the oil phase. If we alter this ratio, then also this phase inversion occurs. In this method, oil in water type of emulsifier is mixed with an oil, and then a small amount of water is added. Since the volume of water is small compared to the oil, water in oil emulsion will be formed. Okay. So, if we have not properly adjusted the volume or the ratio of the oil and water, then there is a inversion of the oil in water to the water in oil type of emulsion happens. As more water is added slowly, the inversion point is gradually reached, and water as well as emulsifier envelop the oil to form a globules yielding an oil in water emulsion. So, we can improve this by adding a small amount of water slowly. Okay. Then what will happen? If we start adding gradually water, then the water and the emulsifying agent, they try to envelop the oil phase, and again we as a result oil in water type of emulsion will formed. So, next is your evaluation of the physical stability of emulsion. So, in this we study how the physical stability of emulsions are evaluated. Emulsions are evaluated for their chemical and physical stability. Chemical stability involves the study of degradation of active drug, emulsifier, preservatives, antioxidants, etc. So, generally the chemical stability shows or includes the degradation of your active drug API, the concentration of the emulsifier, the preservatives and the antioxidants, etc. Chemical instability leads to physical instability. Okay. So, because of chemical instability, physical instability will take place. So, physical stability study indicates the retaining of the integrity of the dosage form during shelf life. So, physical stability study they indicates the integrity of the dosage form. An emulsion is considered to be physically stable if it can restore its initial properties on moderate shaking. So, an emulsion is considered to be stable if it is able to restore or sustain its initial property on properties as it was at the time of manufacture on moderate shaking. The physical stability of emulsion can be evaluated by the following method. First is your extent of phase separation. The practical and commercial aspect of stability is the study of phase separation. Okay. So, first of all, since it is an emulsion, so there is a high chance of getting the two phases separated. So, this is a quick method and can be applied for poorly formed and rapidly breaking emulsion. So, separation of phase is visible after a definite period of time. Okay. Then globule size distribution. An early sign of instability is indicated by the appearance of bigger size globules. So, another method for evaluating the physical stability of emulsion is by measuring the globule size. Okay. So, if there is a change in the size of the globules, that can also indicate the instability, and this is due to the aggregation of the oil globules and the collations of the globules from time to time during the storage. Therefore, microscopic examination of globule size distribution analysis is useful tool to evaluate the physical stability. Globule size analysis is done by optical microscopy. So, globule size determination is done by optical microscopy. Globule size diameter in micrometer can be plotted against on x axis and the frequency number of globules of each size on y axis. So, in this what we do? We plot a graph between the globule size and the number or the frequency of globules on the y axis, and from the graph we determine the size of the globules. Immediately after the manufacture, the emulsion exhibit active collision stage for some period. During this period, the emulsion get stabilized and is relieved of stress induced in the preparation. Beyond this period, the emulsion remains stable on extended storage. So, what will happen when we have prepare emulsion? So, at that time there is a pressure is in pressure is applied on the system. So, when the pressure or the force is relieved, that is the stress is relieved, what will happen? The emulsions in the globules, they try to they are in a collision state for some period of time. Once they are getting relief from the stress which is induced on the system, the system tries to get stabilized. After a certain period of time, the emulsion remains in its stabilized state for extended period of storage. Okay. So, in this way we plot a graph, and from the graph we determine the size of globules. Then another is your accelerated stability study. Flocculation and creamings are slow process. However, these processes are hastened by inducing stress condition using ultracentrifuge. The emulsions are subjected to different centrifugal speed such as 200 to 3000 rpm at room temperature, and the separation of phase is observed at different time period. A bad emulsion normally separates the oil instantly. A good emulsion does not exhibit detectable separation of oil phase until certain time period, that is induction period. So, what we do? We take a series of emulsion and we subject various centrifugal speed, that is around 200 to 3000 rpm at a room temperature. Okay. So, like this, then we plot a graph between the time to the force, that is your centrifugal force, and from the graph we determine that which emulsion or which emulsifying agent imparts a greater stability to the emulsion. Okay. So, generally if your emulsion is bad, okay. So, if your emulsion is poor, then in that case the oil separate immediately, and if your emulsion is good, so they show the separation of the oil phase after a little bit period of time, that is called the induction time or a induction period. Then another is your microwave irradiation. The emulsion is exposed to microwave irradiation. then the surface temperature of the emulsion tend to be the highest, and the temperature gradient between the surface and the bottom of emulsion must be small for most stable emulsion. Okay. So, here the emulsion is exposed to the microwave irradiation, and in this what will happen, the surface temperature of the emulsion, it is tend to be the highest, that is a temperature gradient exists between the between the surface of the emulsion and the bottom of the emulsion, and this temperature gradient, that is the difference between the temperature of the surface and the bottom of the emulsion, should be small in case of the stable emulsion. But if this difference in the temperature between the surface and the bottom, if it is large, then that indicates poor quality of emulsion. Then come to the rheologic properties of emulsion. Emulsified products may undergo a variety of shear stress during preparation or use. Thus, emulsions are evaluated for its flow behavior. The following flow related attributes are desirable for the overall performance of an emulsion. Okay. So, whatever the emulsion is prepared, when we prepare the emulsion, a variety of stress is induced on the system during the preparation. So, the emulsion needs to be evaluated for its flow property, and it is very important for the following reason. First is your removal of an emulsion from the bottle or a tube. So, if we are going to remove the emulsion from the bottle or the tube, that is important. Then flow of an emulsion through a hypodermic needle, okay, that is the flow of emulsion, okay, from your injection or a hypodermic needles. Clear? Then spreadability of an emulsion on the skin. Okay, that is when we prepared a topical emulsion, then their spreading nature, okay, the spreading nature of the emulsion on the skin. Then stress induced flow changes during manufacture, and the whatever the pressure we applied during the manufacturing, that will hinder flow property of the emulsion during the manufacturing. In general, dilute emulsion exhibit Newtonian flow, and the concentrated emulsion show a non-Newtonian flow. So, in general, your dilute emulsions, they exhibit the Newtonian type of flow characteristics, and the concentrated concentrated emulsions, they exhibit a non-Newtonian type of flow. Factor related to the dispersed phase, which include the phase volume ratio, particle size distribution, and viscosity of the internal phase itself. So, these are the following factors such as phase volume ratio, particle size, viscosity. They govern the nature or the rheological properties of the emulsion. Thus, when volume concentration of dispersed phase is low, the system is Newtonian. As the volume concentration is increased, the system becomes more resistant to flow and exhibit pseudoplastic characteristics. So, if the volume concentration is low, the system is Newtonian. If the volume concentration is increased, the system becomes more concentrated, and it is they resist the flow, and hence they exhibit a non-Newtonian type of characteristics. At sufficiently high concentration approaches, if we are going to increase the concentration of dispersed phase very much, that is around 74%, then inversion may occur. So, at that concentration, phase inversion will take place with a marked change in viscosity, reduction in particle size distribution. So, at this stage there is a change in the viscosity of the system, there is a reduction in the particle size distribution. Another factor of continuous phase that affects the flow property of emulsion is its own viscosity. So, these are the factors, the above points are related with the dispersed phase. Now, we will discuss the factors which are related with the continuous phase. So, the important factor related with continuous phase is its own flow property, that is its own viscosity of the continuous phase. The effect of viscosity of the continuous phase may be greater, however, that predicted by determining the bulk viscosity of the continuous phase alone. Okay. So, the effect of the continuous viscosity of the effect of viscosity of the continuous phase is much higher than the overall bulk viscosity of the continuous phase alone. Another component that may influence the viscosity of an emulsion is an emulsifying agent. Okay. So, the type of agent which affect particle flocculation and interparticulate attraction, and hence these in turn will modify flow. So, another important factors which govern the rheologic property is your emulsifying agent itself. Okay. So, we can summarize like this, that if the phase volume ratio is 5%, then that is very dilute emulsion, then emulsion will exhibit a Newtonian type of flow. If the ratio is 50-50%, then the Newtonian will then the system is non-Newtonian, that is it will exhibit pseudoplastic flow. But if the phase volume ratio is 74%, then the system is plastic flow or a phase inversion will take place. Next is your preservation of emulsions. Emulsions are heterogeneous system in which partitioning of the preservative will occur between the oil and water phase. It is important that an emulsion should be free from microbial contamination and growth. So, since the emulsions are heterogeneous system, that is a biphasic system consisting of two phases, oil and water, and in this the if we add up preservative, so that preservative partition itself in between the oil and the water phase. So, and it is since it is a liquid dosage form, so emulsion needs to be free from any kind of microbial contamination and growth. For such reason, preservative needs to be added into the formulation. So, preservatives such as benzoic acid, sodium benzoate, methyl paraben, propyl paraben are employed in the preparation of emulsion. So, we can incorporate any of these preservatives into the emulsion. The optimum concentration of preservative is decided by considering the following features. Okay. So, we can decide the concentration of preservative by considering these parameters. First is your aqueous phase. So, generally the bacteria or the microorganism are generally grown in the aqueous phase and at the oil water interface. Therefore, the preservative should partition in favor of the aqueous phase. Special care should be taken on the use of preservative in oil in water emulsion. So, generally this microorganism they grow in the water phase, aqueous phase at the oil water interface or a junction. So, for to prevent the microbial growth, the preservative needs to partition in such a way that it should partition in the favor of aqueous phase, and if we take aqueous phase, so that it can resist the growth of the microorganism. Another factor is the volume fraction of the aqueous phase. Higher the volume fraction of the aqueous phase, higher is the concentration of preservative required. Okay. So, another is your concentration of your aqueous phase. If we are going to increase the high concentration, if your aqueous phase is present in very high amount, high volume, then you need to add a preservative in high concentration. Then pH of the aqueous phase. The preservative should be in an undissociated form for its transport across the membrane of the organism. The undissociated form is effective as a bacteriostatic agent. The pH of an aqueous phase should favor the formation of undissociated form. So, the pH and the preservative should be present in its undissociated form, so that it can easily permeate through the membranes of the microorganism. The undissociated form is of the bacteriostatic agent is more effective. So, the pH of an aqueous phase should favor the formation of undissociated form. Okay. So, whatever the pH of your aqueous phase is, that should favor the conversion of the preservative in its undissociated form. The following equation is used to calculate the concentration of preservative. So, this the equation will be used to calculate the concentration of the preservative is, that is HA whole bracket W is equal to C KQ plus 1 plus Ka upon H3O plus ion, where C is the total concentration of solid, HA whole bracket W is the concentration of undissociated acid in aqueous phase, H3O plus is the concentration of H plus ion in the aqueous phase, K is the partition coefficient of the acid between the oil and the water phase, and Q is the volume ratio of oil to aqueous phase. So, in this way we can determine the concentration, the required concentration of the preservative into the formulation. Okay. So, by using this formula we can determine the concentration of the preservative, and in this way we can preserve the emulsion from the microbial growth or the contamination. Okay. So, in the last, if we summarize, so we have studied about the what is emulsion, what are the different types of emulsion, what is emulsifying agent, what is the mechanism of emulsifying agent, what are the physical instability of emulsion, how we are going to improve the physical instability of emulsion, what are the various factors, what are the various evaluation parameters of the emulsion, what are the rheologic properties of the emulsion, and lastly the preservation of emulsion. So, all this we have discussed in detail. Thank you.